So, thanks for staying. In the next short presentation, I'm going to talk about technical decisions. My name is Oresztesz Margaritisz, and I work at EPAM as a lead software engineer. So, let's get started immediately. Just a bit clarifying of what kind of technical decisions are we going to investigate today. So these will be typical technology choices, like choosing between a container orchestrator or, let's say, a storage engine, or you have the similar stuff in the build system, or, for example, the typical implement versus reuse example. Right? So I really hope that all of the audience has to do these kind of technical decisions at some level. Now, before we really begin, let's have an exercise with all of you, okay? So, just simply try to recall your worst technical decision ever made so far in your professional career. Now, you don't have to shout it out to the audience, please don't do that. Just recall the memory, okay? And now, if you were able to think about an example, also try to identify the emotions that are bound to that memory. So how have you felt yourself in a situation? You should feel something like being, let's say, upset or annoyed maybe, or let's say ashamed or irritated or exhausted. So for sure, it's not a pleasant feeling, right? But how do we come from knowing that inside ourselves that these bad technology choices are bad for us, from something more concrete? So what is the real cost of a bad technical decision? What could it be? So, what I always being able to identify immediately is that they are somehow sticky. So even though if something seems replaceable, it's very hard to do this kind of rework in the heat of the project somehow. It does not get prioritized in our work streams so easily. They also bring a certain amount of cognitive noise. Now, what do I mean by that? So, instead of being productive, creative, these kind of things, instead of working on features, you start working on things that you shouldn't do. So, you implement workarounds. You get annoyed, upset, interrupted by this bad technology choice. You have to restart, for example, services, these kind of things. Maybe create issues for other teams. For sure, it's not really productive, is it? They also come with this huge amount of technical debt. So immediately after you make this bad choice, you have to carry on this technical debt with you during your project. And also, they have this kind of thing that's called the accidental complexity. So here's how it works. So imagine that the problem that you were able to solve is just the tip of the iceberg. And all these kind of extra features or useless things or issues and so on that you brought into the project is the mass amount of the iceberg that's just beneath the sea level. It's invisible at the first point. But later on, it becomes reality, right? That's what will really sink your project. Okay, now let's forget for a moment all of these things. And now, let's talk about good technical decisions, because that's why we are here. So these should be just the positive opposite, isn't it? Well, saying as simply as it's possible, I would say that they are just solving the right problem. Like a puzzle piece, they shouldn't do really more and nothing less than that. Now, how do we get to this point? To having these good technology choices. We have to have some kind of metrics. So I have to be able to compare each alternative to each other with some kind of fitness function or quality attribute to be able to compare them, right? Now, when I'm talking about metrics, I always realize that there are around four categories for these metrics. They are namely design, learning curve, runtime, and support. Now, if we think about runtime, we can think about things like the software's maturity, the number of years the community put into the refining the software, really. We can think about the API, How easy is it to use? Is it able to integrate with our own ecosystem of softwares? We can think about the feature richness, and especially the features we really need. Also, interfacing, is it replaceable? Can it be integrated at all with my own tools? And of course, simplicity is in many cases a huge driver when you are working in a complex environment, right? Okay. Now about learning curve, the quality of the documentation, its usability. Think about like a intuitive web UI, or maybe a command line tool that can be easy to use or can be very difficult to use. Fast feedback is necessary for fast development, right? And of course, the team expertise. So every team member comes with a certain expertise to a problem, of course. Now, if you consider runtime, you can think about things like the technical constraints. That's also a major driver. So again, it has to fit into our existing ecosystem of software. We have an existing requirements that it needs to satisfy, right? Like I want to communicate through SSL TLS, for example, or I have to integrate with an existing tool that I have, these kind of things. In many cases, you look for solutions that does not bring a single point of failure. You can think about performance, of course, about its stability, so I don't want to deal with rebooting services and so on. And of course, security is also a major driver in many cases. Now for support, you can think about debugging, logging, about monitoring, of course, about the exceptions, so how informative are they or not. And in many cases, you want some services that does not tend to become snowflakes. If you don't know snowflakes, typically hard to configure, pluggable solutions become these monolithic services that take ages to restart, for example. And you need to think about testing. So everything that you work with has to be reproducible in your staging environment and in the development environment really easily. Okay, so this is the big picture of metrics that can be used, right? And what we are able to recognize immediately, that it's not self-explanatory. And the majority of the work is really just dropping those things that you don't need, really. So you have to contemplate over this big picture to figure out that which ones are relevant for your project, because you don't have time to investigate everything, right? The complexity increases really easily. Okay. Now, how do we measure these metrics? Let's see a few examples, some practical examples of how to do this really quickly. Okay, now if you think about maturity, you can investigate existing statistics like Google Trends, comparing the popularity of certain keywords. You can use this funny tool, for example, to compare the popularity of programming languages. Is it an increasing or decreasing trend, and so on. And there is a very, very useful tool that I use for most of the cases, which is called Stack Overflow Insights. When you, for example, can look for certain tags, you can look for the most desired technology, these kind of things. Now, for technical constraints and feature richness, a simple checklist will do. But in many cases, the majority of the work is that what you put on the right side, what are your real requirements that you are looking after. Okay, because that's what you have to think through carefully, and that's the majority of the work, really. For design simplicity, API, and stability, often I just do a static code analysis. That will do. If you know what the real metrics means inside the code analysis. Now, for stability, you can look at the existing issues. You can look at the project statistics. You can look, for example, the open bugs and so on, the release frequency of the software. This can be good metrics, for example. Okay, for performance, of course, you can use an existing performance measurement, but you have to also be familiar with the measurement, how it was made, what they really measured. Now, and of course, yeah, security. For security, you can look at the open issues and statistics, how many of them were closed, and so on. Now, but this talk should be really about how do we make these decisions. So let's investigate the process itself and the approach itself, and let's try and refine it. So for sure, I'm looking for something that's a breadth-first approach. So I need to investigate as many alternatives as possible within the shortest time frame I was given to me. Okay. So usually I use lean software development methodologies to do this. I found two of them very useful. Namely, the first one is set-based design, which is simply delivering as fast as possible. And the second one is last responsible moment, or saying it differently, just deciding late as possible, deferring our decisions. Okay, here is how I would use, or here is how I use set-based design. So let's split the team as many metric as we would like to investigate. Let's say one of the members will investigate the cheapest solution, another one will see what's the fastest solution, and the third one will see the easiest solution, or try out this easiest solution. And of course, our ideal choice is right in the middle, but it might not exist, okay? Because in many cases that's the reality. But what can happen is that, for example, it turns out that the open source solution, or the cheapest solution, is not so slow. Or, for example, the fastest solution has really bad documentation, and it's really difficult to use, so it's not easy to use. So after each of these team members figure out how these things work in your context, you can get back together and discuss your experiences and figure out which things are worked for you, which ones did not, okay? Now, if you want to use the last responsible moment, you need several design decisions and design your software around that. So I'm thinking about simple things like parallel dependencies. Many solutions allow these kind of things. For example, you have to use interfaces and abstractions to hide your implementations. And after that, you have to use feature toggles. So I need to turn on and turn off each kind of alternative independently. And it's really a commitment from the team to do this kind of design around the solution that I'm going to use, and around the different kind of solutions especially. And at the end, you can use deprecation, figure out that what's the least used alternative. Let's just drop that. For example, in one of my latest projects, we used like 3 different database implementations for the same thing. And after a while, the application just did not start with one of the settings. And we know exactly that this is the moment when we just need to get rid of the traces of the code from the code base. That was so easy for us. So this can work really well, I think. Okay, now I say that we still have a missing key ingredient. And what could that key ingredient be? I think what's really missing is our own thinking of how we think during this decision-making process, because it really affects the whole process itself. All right, so how are we able to improve this kind of thinking mechanism of ours? Let's see a few examples. Okay, now first it could be obvious, but let's work as a team on all these kind of things. So we have to honor actually approaches that simply just gather all the experiences of each member and tries to use it. And it seems really simple, but I've seen many arguments, for example, many emotions during these conversations. And you are not thinking, for example, in moderation. Or there is a term called group intelligence that talks about how different kind of activities of members are going to leverage the whole IQ of the group or are going to diminish the IQ of the group. For example, if somebody is too dominant or if somebody is too introverted, they won't participate. Okay, you have to use your intuition wisely. So we need an approach actually that allows space for rational thinking as well as intuitive thinking. And you don't have to mix and match these kind of things. So it's not really just a shooting at the first solution, following my gut feeling and just hacking out the thing that I want and saying that that's going to be the technology that we use as a POC or something like that. It should be more than that. And we have to remember ourselves during these teamwork activities, we are aiming really for breadth-first approaches. So we have to investigate as many things as possibly we can safely. And I have to emphasize that during these activities, we have to be able to remain calm and collaborative. Now, why I'm saying that like that? Because I've seen many, many arguments when colleagues having coffee over just simple technology choices, like a holy war, right? So everyone has a favorite, and instead of pushing your favorite, you have to understand others' viewpoint. So you have to use active listening skills. You have to ask clarifying questions, or maybe just be quiet for a moment and figure out what's going on during these group activities. Okay, so these things really make a difference. And it's not really about just picking the best technology and so on. Good. Now, I would like to give you as an example of how I'm combining these things to my, let's say, awesome decision-making recipe. So treat it as a recipe. Okay, just motivate if you would like to try to experiment with it. You can use part from that, drop those things that maybe doesn't make sense or you don't want to use them. Okay, now step 1, get away from the computers. Why do I say that? Because typically it's hard to be creative and productive when everybody is sitting in front of computers. There is no conversation really happening. Step number 2, pick not more than 4 to 7 metrics, and tend to have just 4 when you have around 2 weeks for the decision to be made. If you have more than 2 months, only then try to pick more than 4, 7 maybe, but that's going to be too much. You have to use brainstorming effectively, meaning that the quality of the alternatives at the first step of the brainstorming doesn't really matter. You can drop off these things that obviously won't work later on. But try to brainstorm your alternatives as well as your metrics as well. Then you collect the measures. It can be done separately, individually, and so on. And you get together and rate each metric from 1 to 5 stars. So it's abstract enough. It's subjective enough, but it allows everyone to participate, and you can use your intuition during this process. Okay. So if you have any kind of disagreement on these cases, you can use these kind of lean methodologies. So after that, typically we discuss how do we defer these decisions, what kind of design has to be made around that if we are not sure. Okay. Now, in summary, what I would like to say is that the approach itself, how you make those decisions, as I've seen, in many cases, is much more important than was the concrete decision that you have to make. And what I want to leave you with is that in many cases, it's not technical. So if you remember your worst technical decision, your worst technology choice in the beginning of the talk, try to go through the presentation and see how you can improve, how you could have been improved in a situation. And in many cases, you find that it's the approach that you have to improve, or maybe your own kind of approach or thinking for that decision. Thank you very much.